This is a short video on the major components in an analog or subtractive synthesizer. The first component is called the VCO, or voltage controlled oscillator. This generates the sound. It can generate waveforms, such as sawtooth or triangle, or even noise sounds too, which are actually just random frequencies and random amplitudes. Now it's called voltage controlled because originally the oscillator would know what pitch or frequency to generate based on which voltage it received. For example, if a keyboard was attached to this oscillator, the keyboard might generate a 1 volt signal, and then the oscillator would know, oh yeah, 1 volt is C. Or maybe the keyboard would actually generate a 1.5 volt signal, and the oscillator would know, oh no, that's a C sharp, and so on and so on. So it would know what pitch to generate based on the voltage of the signal that it was receiving. And we've hung on to this voltage controlled because that's where it came from. So it's VCO. It generates the sound. Unfortunately, the sound it generates is quite boring. It's a very pure waveform, a pure square wave or a pure triangle wave. It's not very musically useful. Now, these waves have quite rich harmonic content, which means they have lots of actual high frequencies and low frequencies even within this signal. But they still sound quite boring. And to shape them, we need to shape the harmonic content. So we need to tune these frequencies. We need to turn some of the highs down, some of the lows up, etc., etc. And we can do this through a VCF, or a voltage-controlled filter. Again, we've hung on to the VC part for some reason. So this is the VCF, and it generally takes parts of the sound away. It's generally a high-pass filter, or a low-pass filter, or a band-pass filter, and it's generally subtracting harmonic content from the sound, subtracting high frequencies or low frequencies. And because of that subtraction, this synthesis type is also called subtractive synthesis. Now, it doesn't have to subtract, it can boost, but generally we're talking about taking things away rather than boosting them loads. So we've got the VCO and the VCF, but none of this would be any use without the VCA, the voltage controlled amplifier. Now this amplifies the sound so that we can hear it, but much more interestingly, it can change the volume over time. So maybe you want a sound like a snare drum that sounds very quickly and then is over very quickly. Bang! Just like a snare drum being hit. Or maybe actually you want to try and model more of a cymbal sound, and the cymbal sound starts reasonably quickly, maybe slightly slower than a snare drum, but then that sound of the cymbal shaking and shaking and shaking for seconds, for maybe 10, 15, 20 seconds. The sound is really long. Now, to shape this volume over time, we need the VCA, and we need what's called envelope controls within the VCA. Now, I remember the order of these three components because they're backwards compared to the alphabet. Now, A is the first letter of the alphabet, but it's actually the last component in this chain, and that's to remember that A is at the end, and then F is in the middle, and then O is at the start. So you always start with the VCO, the VCF, and then the VCA.